guys, here's your lesson for Wednesday, April 15th. We are going to start the new notebook, Energy Transfer Investigation 4. Yesterday, you should have answered the question, how does an electric motor work? And making a prediction by saying, what do you think? So what do you think? How does an electric motor work? That was on page 2 of Class Kick. Today, on page 3 of Class Kick, you're going to draw and label a dissected electric motor diagram. But first, we're going to do some review on electricity and magnetism. What happens with magnetism when an electric current is running through a wire? What is present? If you said magnetic fields, you are correct. Electricity flowing through a wire coil creates what? It creates a temporary magnet or an electromagnet. What happens when you put a compass near an electric current that's running through a wire? We did an investigation on this, so you should know. The compass needle will move when there's an electric current flowing through a wire. Today we're going to talk about motors. You probably have not seen one this small. You've probably seen bigger ones, but this is an electric motor. If you look at it, there's some different components. You can first see the wires. There's a metal case. This small metal piece that spins is called the shaft. There's also a plastic piece that is on here. Do you think that we could get information about the motor without looking inside of it? Yeah, we could use a compass to see what's inside. The compass will help us determine whether there's magnets inside or not. Here is the compass not moving. When I bring the motor towards it, it moves the compass. So there must be a magnet inside of it. Could the compass needle be moving because there is an electric current inside the motor? No, it can't be moving. This is not part of a circuit. In order for there to be an electric current going through it, we have to connect it to a battery source. So I'm going to show you what happens when I connect the motor to a battery. I currently have one wire hooked up. Now let's see what happens when I hook up the next one. As you can see, when the motor is hooked up to the battery, the shaft rotates very fast and it makes an interesting noise. Now I'm going to show you what a motor looks like dissected. There are 3 different parts. First, we have the motor cap and brushes, which is right here, which I'll show you a picture printed in a second, because this might be hard to see. Next, we take the shaft out of the casing. So this tiny piece is the shaft. In the shaft, there is a commutator, which is a copper casing. And as you can see, there's little slits in it. There's 3 parts to it. There are also 3 electromagnets. If you can see, there's a bunch of coiled wire. That's the electromagnet. There's 3 of them. We know that when there's coils and they're touching metal pieces, it creates that temporary or electromagnet. Now I'm going to show you the parts in picture form. So here we have the motor cap and brushes. The brushes are those tiny copper pieces. And then the cap was plastic. Next we have the motor shaft and commutator. So here's the commutator. That was that copper piece that had 3 slits in it. That's why they call it gap and commutator. We have the shaft, which is the metal piece. And then we have the electromagnet section. So that's where the red coiled wire was. And here is a example of a dissected motor into 3 parts. So this is what I showed you, all 3 parts: the cap, the shaft, and the casing. So there are 3 things you should take away from this. First, the coiled wires looked like they could be electromagnets. Second, magnets are attached to the inside of the metal casing. And I'll show you that right now. There is a magnet inside this. See how it doesn't necessarily fit right there? And then you just stick it through. So these thin wires in the inside bring electricity from the outside. So the electricity goes through the wire and through these brushes, which then goes into the motor when we connect it. It hits the shaft and then the electromagnets. So there are magnets in the metal casing. They're permanent magnets, which means they never lose its magnetism. We can also test to see if it's a magnet by putting a paper clip in it. Yep, it's a magnet. I'm going to explain how this works again. So, once it's connected to an energy source like a battery, the current goes through the wires, goes to the little brushes in the inside, hits the permanent magnet, goes through the shaft, and turns on the electromagnets. However, the electromagnets don't all turn on at once. That's because the little copper piece, called the commutator, acts as a switch for these 3 electromagnets. It's not possible for all 3 electromagnets to go at one time because there's only 2 contact points in the cap. So only 2 electromagnets will work at one time. So now we're going to review. What happens to each electromagnetic section when a current runs through that section? The electromagnet will turn on. How will the permanent magnet interact with the electromagnet? It will either be attracted or repelled to the inside casing. I'm going to explain why the electromagnet only turns on 2 at a time, or the commutator turns on 2 at a time. When 2 sections of electromagnets are turned on and 1 section is not, those 2 on sections exert a force on the permanent magnets inside the case. As the on sections attract or repel the permanent magnets, the force causes the shaft of the motor to rotate. But as the shaft rotates, the commutator also rotates into a new position. Suddenly, the section that was off is turned on, and one of the previously on coils turns off. The electromagnets exert a force again, rotating the shaft again. This process repeats over and over and over, creating an electric motor with a rotating shaft that could drive a toy car, spin a washing machine basin, run a blender, or do countless other jobs humans might dream of. The brush and commutator system is a kind of switch. The rotation of the shaft opens and closes the circuits, turning the electromagnets on and off. The design of the commutator switches on and off the electromagnets at exactly the right time to keep the shaft rotating. Now we're going to discuss the energy that comes from having a motor in a circuit. What evidence do we have that there's energy in that? We know that the shaft is turning, so that's energy of motion or kinetic energy. Where did the energy come from that transferred to the shaft to make it move? Well, we know that the battery has chemical energy, which then gets turned into electrical energy through the wires. And then to the shaft, it created kinetic energy because the shaft was moving. So there's all types of energy in our circuit. Here are the pictures again so that you can draw. I'm really more concerned with you drawing these 3 parts. You don't really need to draw the other 2. So the casing, the shaft, the cap, you could label the electromagnets, the commutator. So I'll go back to that. So I like this picture, but you can still label all these parts. And if you need to pause this video at any time to help you draw and label, please do so. That is your lesson. I hope that you have a great day. If you have any questions or suggestions about the video, please feel free to give them to me.